making the entire world a single a village or kind of things. So what is this IoT? Things, right? So things means that it is no more the internet of computers alone. It is no more the networking of the people alone. It's beyond the machines, beyond the computers. So we have been talking about the computers, be it desktop computers, laptop computers, tabs, or mobile phones, etc. Okay, that basically is a gadget. The individuals like us, we use it. But apart from that, the people thought anything in the world need not have to be a computer, right? Need not have to be a desktop kind of things. Anything, any device can become part of the internet. So that is how people thought about it. So that the health of the things, or their functioning of the things or non-functioning of the things, behavior of the things, everything can be tracked. The people, in fact, want today to have such kind of things, right? So that is a basic idea behind Internet of Things. Needless to say that all the participants in this webinar might be having a fair idea of the computer networks, I believe. So when Internet has evolved, when the number of computers connected by means of the network started evolving from few thousands to millions and trillions of today, they have had some kind of IP scheme, the Internet Protocol addressing scheme, where they anticipated that yes, let us give some 32-bit number that should be sufficient. So 2 power 32 number of computers is huge. The people thought that will be the target beyond which there may not be any need in those days. But later on, seeing the trend, the exponential growth of the number of computers, the computers themselves, I'm telling, I'm not even talking about the things, the computers, getting connected with the internet tremendously increased. There was a need for rethinking of the addressing scheme. The people thought, it's not sufficient. It's very similar to like what we have had those days with the landline phone. The numbers used to be some 5 digits, then they have expanded to 6 digits, 7 digits, etc. So number of digits need to be increased, because as and when there is a demand, more demand comes, then the number of digits that are required to uniquely identify endpoint need to be increased. So even though in those days, these people, the computer ancestors, have uh, made up their mind that 32 bits of this particular thing should be sufficient. Then on seeing this, the rate at which the need for computers joining the internet increased, they thought this 32 bits would really not be sufficient. It will saturate one day. It will cause a lot of chaos in the world of internet. So that has led to the development of another IP scheme, the advanced version of the IP scheme. What is that? That is IPv6 versioning, right? Versioning. So the people came out with the versioning, interesting versioning. So they have, they did not even double it. It was not like 132 became 64 and kind of things. They immediately drastically taken it to 128 bits, anticipating that there will be a huge amount of computers. In fact, that is one of the driving factors that indeed helps realization of networking of anything in the world. The anything includes a computer, and hence a person like us. And apart from that, anything you name anything, maybe this pen, maybe even a button that is there in my shirt, or even the specs that I'm wearing, right? Anything can be tracked in the internet, provided it is enabled with the internet. So this IP scheme started helping that, right? So people always want to monitor something, right? So monitoring the something normally happens through the devices called the sensors. Sense the environment around us, and we want to take some decision on that particular thing. Please remember, the world is analog in nature, whereas the computers, the philosophy behind the computers were those days to solve numerical problems only. So people started developing only the digital computers, which can understand numbers and binary arithmetic only. But the world is not like that, right? The world around us is analog in nature, be the temperature, be the pressure, the wind flow, humidity, and whatnot, anything that you name, the lighting around us, everything. We cannot say, yes, there is a light, there is no light, right? It is too hot and it's too cold. We can't say like that. We want to quantify it precisely, accurately. That is what is very important. So in order to take all those things, we need to have some kind of sensors. Thanks to the instrumentation engineers who have been continuously working on coming out with the transducers. Otherwise, they are called as sensors today. So which helps to transform the physical quantity such as heat wave, the velocity, etc., into electrical signals, equivalent electrical signals, where changes in the currents or the changes in the voltage or the resistance, etc. Right? These embedded system designers, the electronics engineers, came out with with the advent of the various microprocessors and microcontrollers, the RISC architectures, etc. So they were able to come out with the programming of all these kind of things and creating very interesting applications, right? So today, in the context of the Internet of Things, we call a thing a very small thing, which comprises of some kind of embedded computing inside of that particular thing, and then it has got one or more number of sensors which would actually monitor the the environment around us, and of course, in order to give life to the embedded system hardware, we also need to have some kind of software, and there are a lot of challenges in developing software for the embedded systems, and hence developing software for the Internet of Things also. And of course, just a thing now, it's like a small form factor computer, but the idea is that we want to track it from any corner of the world. How do we do that? So that requires communications. So we want to have some kind of communications, so technologies for connecting and exchanging of the data over the internet systems over the internet is very, very important. So basically, Internet of Things requires computing within a thing. It is a hidden computer, a computer which is hidden behind anything that you want to monitor in your life, and then it will have a set of sensors, and the software gives life to that, or you call them as a firmware. And then, of course, we need to have some kind of communications technology, right, and some kind of protocols, and try to leverage the already developed internet technologies, and don't reinvent the wheel. That's the whole idea, right? Reinventing the wheel is always not a good idea, especially in the engineering field. So you try to learn lessons from the past, and then you try to come out with your own innovations and then fine tune that particular thing. And that is why it is called, still that name internet still is there, but explicitly tells that it is Internet of Things. It is not mere an internet. So the devices can ordinarily be household objects, as simple as that, or it can be some sophisticated tools also, right? So this terminology, or this particular technology, IoT, rapidly transforms the way that we live, work, and then interface with the world around us, and makes our life smart. And we call today by various names: smart home, smart city, right? Smart factory, and so on and so on. So people always want to be smart enough. What is that smart enough? Even today we are very smart enough, right? Sitting from my home, I am addressing, and many of you are sitting from your home, very smartly. You are also listening to that. So we don't, I don't have to now travel all the way to Bhimavaram, which is some 200 kilometers away from here. Spending some 2 days over there. It's not required. It's just this 1 hour only we connect and exchange our ideas. So the internet facilitates this particular thing. Similarly, the IoT makes our life very comfortable, right? Various things can be tracked. And many of you may be having CCTV cameras at home for the security surveillance, right? So when you travel outside of your home, what happens is that you take your mobile phone, and then you get connected with that particular set of cameras, CCTV cameras mounted at a thing, and then you just have uh, have a very live view of who is coming around, what is happening around, all such kind of things. You're actually seeing that. That makes in your world very smart. Even the factories, even the shop owners, they are able to see what their employees are doing at different floors or different branch offices, etc. And then that increases the productivity, all such kind of things. So definitely the IoT transforms our life, and the way that we work in this particular world. Well, so how do we see the IoT in the context of the architecture itself? Just 1 minute. So this can be seen as if it's architected with some 4 layers. Layers are only the abstract layers. We don't physically see that. We look at the IoT as if it is organized as 4 different layers. The bottom layer is a sensing layer. Okay, the bottom layer is a sensing layer. Where it interfaces with the external world. Physical objects such as sensors and actuators are connected over there, right? Sensors and actuators. What is an actuator? Sensor, just now I told you, is like a transducer from the instrumentation engineer's point of view, which converts the physical quantity into the electrical signals, time varying quantity, etc. Basically, it is used to monitor the environment. Sometimes we also want to act upon the environment. For example, you see some fire. I mean, there are a set of sensors which detect the smoke, and then if it is likely to fire or already fire is caught, what do we do? So, if you are very far away from that particular object, if we provision with that some kind of actuators such as fire extinguishers, some kind of water pumping, etc., this can be immediately triggered without even with the intervention of the man. So it can be automatically triggered so that that particular thing can be arrested. So we have two kind of things. The one that monitors, gathers the data and then gives to us. Another thing is that an actuator which can respond to the commands that are given remotely or by the processor or a microcontroller, which is programmed to act upon the environment depending upon the cases. So all these things are available in the sensing layer. So basically the data gathering takes place up here. Data gathering. It gathers the data periodically, now and then, or on demand, whatever be it. So they will be just collecting the data. What is the temperature? What is the humidity? Right. So all such kind of readings will be gathered. So basically, this, as I already told you, this will have an embedded system. A small microcontroller will be available. It need not have to be have to have a very powerful, resource-rich processor over there. The resource-rich processors are required. High-end processors are required only in the computers, like with laptops or servers and kind of things, because they have to do a lot of operations. But here, their role is very minimal. Okay, you trigger some kind of sensor and find out what is that value, store it in a memory, right? Store it in a memory, that's all. That also need not have to be done continuously. It is going to be done in a periodical manner, maybe once in 2 hours or once in an hour. So in between, if it is once in an hour, in between, there is no job at all. It is not going to do anything. That particular processor and the memory subsystem that is available over there is not going to do anything, right? Literally, it's not going to do anything. But it should wake up. It should, wake up and then, do that particular thing automatically and then keep everything over there. So data gathering takes place. What do you think about the data that typically such kind of sensors or that small the thing that it is going to generate? That purely depends upon the applications. Okay, as I just now told you, if it's an industrial application where you want to measure some kind of what do you call temperature or some physical quantities, etc., That's very, very minimal. The data that is going to be generated is going to be lightweight, I would say. Hardly it is going to take some 10 bytes, or maximum it is going to take 100 bytes per, I would say, per sampling, right? So it may have to store something like the time of sampling, at what time it has captured, and what is the value that the physical parameter has been captured, assessed, calibrated, etc. All these things are going to be stored there, and it is not going to generate an email. It is not going to have a chat kind of thing. It's not going to stream an audio, etc. So the size of the data is very small. Understand? So all such kind of things are kept on stored into the memory. The next thing is data transmission. So how long a device can store the data within itself, right? So we would like to want to have a complete picture of environment, right? For example, in industrial chamber, right? What people will do is that they would have mounted temperature sensors at various altitudes. So all the data that they want to gather, all the data that they want to gather, and then come to some kind of and I mean, you do some kind of analysis on that particular thing, and then you take some kind of decision. So data has to be taken to a centralized base station, you call it as. It has to go to some kind of handheld device or some kind of server, etc. It has to go. Understand? So the next level will take care of that particular thing. The data transmission. The data that has been captured and then stored here should be transferred to the intended recipient, which is actually done through this internet concept. So you have the internet gateways, and you will use all the network technologies, routing algorithms, medium access kind of things. Everything that we studied in the networks will be applicable here. Okay, so data transmission techniques. It can even leverage the cellular mobile phone technologies also, cellular networks also. It may not have to be an IP network. It can also take advantage of cellular networks also for transmission and reception of the data. The next layer is a data processing layer, right? Data processing layer. The data, need to be processed, and it is typically processed after receiving it through the transmission media. So as I just now I told you, it goes to it goes to a server, right? Or you call it the base station, right? BS in short, they call it as in the context of the wireless sensor networks. It goes to that particular thing. And then the data that is accumulated not only from one particular device, but the data that is coming from different devices, different types of data, the veracity of the data, everything need to be analyzed, right? All these things will be analyzed. And after analyzing, take some decisions based on the observations, based on the knowledge that we have gathered so far. Some kind of decisions need to be done. Some kind of inference on the data need to be done. So that should be, given as a form of a report, or sometimes decisions may call for, actuating some of the actuators at a selected place. All such kind of things need to be done over there. The data processing layer is required, and then up above that we have application layer. So where using which you can develop some applications that really make your world, your living style, everything very smart. And you should be able to manage also, right? The device management also need to be done over there. In spite of going to the places very easy, it may be sometimes very difficult to access the places where these kind of sensors or the things, the endpoint devices are being, launched. It may be practically very difficult for you to go physically there and do that particular thing. If you go physically and do that, that means we are no more smart, right? So we go back to the way that our ancestors have worked before the advent of this kind of IoT kind of technology. Right. So we should be able to have a smart application. We should be able to smartly manage every devices also. That is very important thing. So this is a very simplified architectural view of the IoT. How you look at that particular thing. It also tells, if some from the student's perspective, I would say, okay, there are 4 layers. Which layer I have to learn and I have to become master? It all depends upon your interest that you develop. If you're a good programmer, right? If you think that I can solve any kind of problem, I have very fair knowledge in the database applications, the tools, data processing, data analytical tools, then your domain is certainly at layer 3 and layer 4. Okay. And if you are at the networking, if your areas of interest are the networking, right? You want to provide network, troubleshoot network. If the device is not getting connected, you go configure and you put some kind of firewall, etc. If you think you are really good at it, if your area of interest is inclined to that, naturally you will have to focus on this particular thing, network layer. Still further, at the bottommost layer is the sensing layer. So this area is meant for those who understand the computer organization and who can design embedded system applications. You can understand what is a microprocessor, what is a microcontroller, what is an assembly language, right? And kind of what is a register, what is a real-time systems, and how do we connect with the interfaces, such as how does the USB works, how does this Wi-Fi works, all such kind of things. Sensing layer is your domain, I would say. So basically, you see at the 4 different layers, layered architecture in this particular thing, IoT, and then the people work together. And finally, you get the benefits out of this IoT is considered. So when I say IoT, before the advent of the IoT, or in fact, I would say the wireless sensor networks, WSNs, are the root for motivation of this particular technology, I would say. Right, the wireless sensor networks evolved in the early part of the 2000s, or even at the later part of 1990s, I would say. The concept of wireless sensor networks. Even before that, industrial automation was very much needed. There were a lot of revolutions took place in the industries, be it the food industry, be it the automobiles industry, chemical industry, everywhere. Right, the industrial revolutions took place, and that only caused the World War II and all that, as may be aware, right? So 1940s, or even before that, even in the 18th century also, there was an industrial revolution taking place, right? With the advent of the mechanical engineering trends and all that, people were doing that. But in those days also, when the electronics technology matured enough, the people had these similar ideas, monitoring the environments, right? Monitoring the environments, the concepts of transducers. They're all very old topics. How to measure temperature using a thermostat, thermocouple, right? All these kind of things were existent. Very well, they were existent. But the thing is, they were connected by means of wires in those days. They need to be connected by means of wires. But if you connect with a long distance, as you might be aware, the resistance offered by the wires enormously increases, and then it became very difficult for the people to remotely make some kind of measurements. So there has to be some localized measurements. You go physically, gather the data, and then bring it to your computers. So all these things were done out there. The moment the wireless technologies slowly matured enough, the people started learned using the unused frequencies, especially the high frequencies, beyond the high frequencies that were used for broadcast applications like radio, television, and all that. There were a lot of frequencies which are not suitable for these technologies. People thought, those things, if you use it, yeah, so many things can be done. So the RF technology. So that has helped in slowly coming out this kind of remote capturing of the data with advent of wireless communication, eliminating the need for physically connecting the devices, wired communications. Everything is now remote. That is the basic idea. So the moment wireless sensor networks came into existence, of course, it didn't come into existence, I would say. It was all only the theoretical thing. People only anticipated the world is going to go like this. So we can connect devices like this, and we can, design some kind of protocols. Then people debated, no, whatever the protocol that are available, which are designed for the wired networks, will not work for the wireless. classical problem I want to tell you is that a CSMA CD. When the wired networks came into existence, the CSMA CD, carrier sense multiple access, sharing the channel, sharing the wire by different devices is very much important. If that sharing is not there, then you have to have, just imagine, one-to-one connection, which is totally impractical. So sharing is very important. But when you share it, there is always a possibility that, if there is no mutual agreement, the communications collide with each other. So the collision reduction, people did it, CSMA CD. But these kind of wireless technologies came, people said, no, that will not work out here because the communication range is very much limited. So we need to have some kind of avoidance mechanisms. So likewise, even though the physical layer simply got changed from the wired domain to the wireless domain, but the idea, all these kind of things remain the same thing. Data communication part remain the same thing. The change in the physical layer, there is a wired versus wireless, has dramatically changed the way that every protocol need to be redesigned. So I would say even my research was also on wireless sensor networks. So I did some work on the MAC layer and a network layer, transport layer, and all that. But they're all like yet another protocols. Not all the protocols that we think, design, and then publish in the research papers will not come into reality. Only I would say 1% of the works will be accepted by the consortiums, and then that will be in use. But even otherwise, the problems are interesting. The way that you look at the problem, you give a solution, everything were interesting. So they were all in the research domains only. You take a transport layer, you take a network layer protocol, anything. There used to be thousands of ideas, I'm saying, right? Thousands of ideas with, small minor changes. So the people used to tell that, this is having a performance improvement of a 10 percentage or 15 percentage. Okay, yeah, it's well and good. So what? That kind of things. But slowly, when the industry 4.0 revolution took place, right? Industrial revolution 4.0. Today we call it as industry 4.0 came into existence, where everywhere the automation is very much important. The people felt the need for the machines interacting with each other, right? The internet facilitates connecting the people by means of course, the computers. Again, it's a machine, but even though the two machines were used as a tool, but it is the people who are connecting with each other. The people felt the need for machines to interact with another machine, thereby some kind of coordination take place. M2M came into existence. Okay, and then with the advent of these wired networks and wireless networks, satellite communication, and all that, you simply call it as access networks. They were able to come out with a lot of MTM, machine to machine device domain kind of things came into existence, smart city and all that. This is the ideology just before the advent of, I would say, the IoT, right? So basically, the machine to machine, as the name suggests, they were designed to take advantage of the communication technologies, satellite communication technologies, wireless communication technologies, etc., with of course the software and other kind of things. And the main idea behind that one was to establish communication, peer communication among the machines themselves, not with any other thing. But the concept of IoT is not like that. But it is beyond that. It is machine to machine, also man to machine, and vice versa, and anything to anything also. That is the idea behind that particular thing. Well, having said the roots of the IoT, let us formally define what is IoT. As Wikipedia or anything that you see, any standard textbook you see, would say the Internet of Things is a network of networked devices. What is it? It's a network of networked devices. Already we have a lot of networks, and then you form another network like that. Network not only devices, it can be a machines, and of course, this is very important. And other things, the things that does not include the machines, which we call, or the devices, anything in that particular world. Okay, that may be equipped with sensors. The thing, for example, the specs, we cannot be called as a thing of internet. because it's not having any sensors and it's not having any circuitry, it is not having any software. But everything is provided, then it becomes a thing, right? So that should be essentially equipped with sensors, some kind of circuitry, and of course, it should be given some software, right? To gather, what does the software do? To gather and exchange the data, to gather the data and then exchange the data. Okay, so this is a formal definition of IoTs. So having said that, the things are enabled with the sensors. What are the sensors available today? Numerous sensors available today. They are available, readily available in the market. Anyone interested in doing some mini projects or mini major projects, readily these kind of sensors are available. You if you're really smart enough, you can just buy it online also through Amazon or other kind of things today. They're all available today. So this slide shows you a wide range of sensors. As the name suggests, for example, there is a sensor for motion, right? The accelerometers for assessing the velocity of the vehicles and all that, gyroscopes, flow and gas sensors, infrared sensors, optical sensors, light ambient sensors, image sensors, where typically they are used in your CCTV cameras and all that. Like that, you have several things: smoke sensors, LDR sensors, rain sensors, right? And it's not an exhaustive list of it. So you have a lot of sensors that are available, and those sensors basically are compatible with the layer 1 platforms that are available today. There are many Arduino boards are available, ARM boards are available, right? Raspberry Pi boards are available. So today, developing an IoT application is as simple as procuring the components and then learn little of the programming. You don't have to go in depth into the programming also, because the programming itself, we have a lot of leverage has been given. I mean, the library functions are available. Only thing is that you have to have a clear cut idea of what you want to do. What is the application that you are trying to do that, and then very seamlessly you can. Anybody, even school students, can do that particular thing. Okay. So there's another interesting way of a survey of sensor applications for a smarter world, which gives you about what kind of sensors are used percentage wise, very interestingly. And this is found available in this paper, IEEE Transactional Magnetics. So as you can see from here, there are humidity and moisture water sensors, which takes about 12% of the share of all the sensors that are typically used. Chemical, gas, acoustic and sound takes only some 1% of the share. Ambient light, machine vision, optical, all these things take a share of about 6%. Whenever we teach as a teachers in the classrooms, microprocessors and embedded systems or IoTs, etc., the very simple experiments that we give is a temperature, measuring the temperature. Air conditioners, refrigerators, everywhere this kind of thing is required. Measuring the temperature is very much required. Okay, so you could see that this takes a major share of that, nearly about 11% next to the chemical or gas sensors. And you have a vibration sensor, RFID, near field communication sensors, and many things, ultrasounds and radio sensors. Many things are available here. So the technology is well matured. That is what I wanted to tell you in the layer 1, in the sensor layer that you see in the architecture. Here's a list of, again, all the sensors. The sensors will be like this. For example, this is an acoustic sensor. This is a temperature sensor, right? Kind of things. They will be very, very small, they can be mounted in a finger or maybe in just 2 fingers. Their form factor is very small, and that is objective of making these kind of sensors also. Because the entire thing that you manufacture should be optimized for its size. It should not be too bulky. If it is too bulky, in the world of corporate, you will experience a lot of competency. Another person would come out with the same application with a small form factor and with the lower cost. Naturally, he will win. He will not be able to sustain in the market. So it's a very competitive world. So people always want to shrink the sizes. Miniaturization is the goal. of all the manufacturers today. Miniaturization also gives an added advantage of low power consumption, and the lower the power consumption, longer is going to be the lifetime. Naturally, the people will be going for that particular product by looking at their specifications. So having defined what is an IoT and just see the architecture, let us now see what are the objectives of IoT. What is the objective of this particular IoT is considered. Okay. So the basic goal of IoT is to build an ecosystem of networked devices that can detect, that can, we can touch, we can interact and communicate with one another. Okay. So it has to create some kind of ecosystems whereby the networked devices can detect. Nobody should tell that there is a device which is compatible with you, kind of things. Okay. So they should be able to sense who are all the neighbors and kind of things. So they should be able to detect it, and then sometimes touch, and then, like for example, robotics, when they cross each other, they touch and then sense their presence and then interact sometimes. Communicate means not by means of verbal like what we do, it is by means of electronic communication that takes place, data exchanges, etc., that take place. That's objective of IoT. Okay. So as I just now told you, uh, the concept of the machine to machine, M to M, basically gives communication among predefined machines only. Now, with the advent of this Internet of Things, of course, we are going to see with the advent of the cloud, so any device can communicate with any other device. It is not customized for a particular machine and another machine. Communication is considered. So having defined what is an IoT and having seen the layered architecture or some insight into the sensors, what are the applications of IoT? Now I said IoT, wireless sensor networks, I would say, did not see much of its existence. The people publish a lot of papers, but hardly ever we could see real life wireless sensor networks in the world. Especially only in the, I would say, automation industry, the industries only, right? But with the advent of this particular IoT, with the taking advantage of the concepts of the internet and IPv6, you see it finds a lot of applications, right? Everyone knows, of course. Let us again revisit this particular thing. The smartwatches, as I told you, the smart, right? So making us, our lifestyle very smart, right? Fitness bands, smartphones, right? The phones in those days, before today we call them as smartphones, before they became smart, the phones were gadgets for personal communication. That's all right? So it will have some endpoint number. That's all. You contact them, right? In the wired communication, in the landline phone, you dial, and then telephone exchange, automatic telephone exchanges connects, it set up a connection, and then till the time you tear down the connection, your voice that is coming through the mouth gets amplified and it goes through the set of pair of wires, and finally it goes there, and then the receiver, reproduces that particular thing. It's analog in communication, right? It was analog all along. There is no question of digitization, I would say. And the moment the cellular phones came into existence, first generation and the second generation phones came into existence, uh, you know, wireless communications. Maybe from your tower, cell phone tower to your phone, it is wireless. But afterwards, everything is wired. We are not bothered about it. It's transparent to the users, right? But the thing is that the moment you start speaking, what happens is that it is converted into digital. That in your mobile phone, not the smartphones I'm talking about, the button phones today we call it as. So they used to have microprocessors or the microcontrollers, memory subsystem. It was a small computer, and it used to convert your voices, speeches into analog signals into digital data, and then that used to go to the endpoint devices. And with advent of the 3G, the third generation phones technologies, 4G and 5G today, and 6G is also expected. With all these things, what happens is that, apart from this voice communication, people started saying data communication. Okay, so whatever that you do with the use of your personal computers in those days, sending the mails, transferring of the files, file transfers, right, and then chatting, all these things, were made possible in the phone, where the phone's main objective was to provide voice communication between the two parties. But now, apart from that, several data services came into existence. But today, needless to say, the smartphones have hundreds of applications, wherein that, apart from making the phone calls, so make really your life smart. Sometimes makes very too smart. Sometimes it may even take you to the peak of frustration level also, because you are tied up with that particular phone. Maybe some of you know, by parallel listening to this lecture, maybe just surfing your phones, WhatsApp, and Facebook, etc. Yes, no, that has become, we are all uh, uh, going after that particular thing only. It takes a lot of our times, right? We can't blame the technology, but we have to change our attitudes, so our preferences, and that is what is very important. Otherwise, really, the over smart makes our life miserable, right? So smart home devices, today we have smart TVs. There are many things, smart lights also, right? The moment that you come in, the light gets on, digital lights, LED bulbs gets on. You can change the color of the bulbs. Millions of colors are available, smart bulbs. Some of you may be having that particular thing, right? There are many things making that environment very smart. Smart cities are very much essential, I would say. Apart from the smart home devices, smart cities, in fact, the various governments of various nations, including our own country, promotes this. They pull in a lot of amount of money. Why? Because the society should become smart. Even every common individual should feel very comfortable, right? The way that the electricity bill is calculated, the way that electricity uh, money is collected. In those days, no, I used to go every month when the bill comes. I had to go stand in a big queue. There will be only one person sitting, of course, with a computer. The computer was there, right? So the waiting time was huge. Sometimes we used to get frustrated. We have to go to our office after doing this particular thing, kind of things. But today, everything became very smart. Even at midnight, 12 o'clock also, if I remember that I have to pay my money, then I can take my phone, and not only the phone, at the back end, the entire infrastructure is made comfortable such that, I don't have to go to the office in the working hour and then do that particular thing anytime, anywhere, anything can be done. So the governments want to make the citizen very smart, very all their activities very smart. The smart cities are coming. How does the smart cities come? With the advent of this particular IoT, automated transit mechanisms, smart monitoring of various activities, home, domestic, industrial, anything and whatnot, conversational interfaces, self-driving cars, and they are not prevalent much today, but I would say after 5 years, you can see a lot of self-driving cars going on, right? Thermostats, implants, even the small things can be implanted today, like uh, for the deaf people, they used to implant amplifiers. Likewise, some medicine, some doctors can actually implant a small, tiny things inside your body. Then they can remotely measure your BP, sugar, and other health conditions, etc. can be done over there. All these things. There's numerous. Whatever that you're seeing here is not an exhaustive thing, but it is various. Yeah, it's a pictorial view of various smart applications, smart utilities, smart mobility. You see everywhere smart. The IoT makes everything smart. The campus smart, right? Appliances smart, tools also smart, right? And of course, agriculture is very, very important. Our nation has to go after the agriculture only. We have to rely totally on agriculture rather than, I would say, the industry, the chemical industry or something like that. But even today, with the advent of this IoT, the farmers can take the leverage of this particular thing so that they can also become smart. They can actually smartly invest, smartly, harvest anything. They can do it today. All the technologies help out there. Smart logistics, right? Smart utilities, everything happens today. Well, having said so much about IoT, its roots, starting from internet and then wired, wireless sensor networks as the forefather of that particular thing, right? And then giving birth to machine M2M concepts, and then coming into reality, the IoT. Today, IoT is prevalent everywhere. It is available. We can't say it is still in research. It is available everywhere. Now, coming to this, the topic that we are discussing today in this webinar is about cloud-enabled IoT. Cloud-enabled IoT. So, it means the cloud computing. IoT itself is already having internet. So, it is connected to the gateway and all that. That is one thing. So, through the existing IP network, whether it's IPv4, IPv6, and all other routers, etc., applications are running, of course. But what is the need for the cloud computing? So which one motivates this particular thing? We'll discuss that in a few minutes as of now. So the cloud computing, by definition, is the on-demand availability of the computer system resources, especially the data storage and computing power, without direct active management by the user. Without this advent of this cloud computing, what happened was that every organization, be it the institution, university, or some government offices or factories, etc., they had to heavily invest on the infrastructure, the servers, the end-to-end devices, networking infrastructure. Not only that, after establishing the networking infrastructures, we need to have a manpower, technical manpower, to maintain it. Otherwise, everything goes wrong. Otherwise, people will say the system is not working, the file is corrupted, the hard disk is not working, there is no connectivity. Another person may be saying it's working perfectly, but no, here it's not coming at all. So all these things, heavy investment in their budget, they have to do that particular thing. With the advent of this cloud computing, right, there are service providers who have already established these kind of infrastructure, the computers, the servers, high-end servers, the data storage, right? Those days we used to, the companies, the organizations used to take the backup of their data. They have to securely put it in their magnetic tape drives or the CD-ROM drives or the pen drives today, etc. But what if they're lost? What if the data itself is lost, corrupted? All these kind of things are coming. So retrieval is a very, very important problem. And then the demand also increases. So as and when the business progresses well and it puts so much of years of experiences, the people would not want to give away some of the files. They may not want to throw it. The data, the file that is available some 5 years before or 10 years before may be useful after 10 years. That will be required. So preservation of the data is also very important. So the need for the data storage also increases. Leave away the time, effort, manpower, everything that is required for the maintenance, etc. So now we have service providers who can do all these kind of things. So you have zero investment on the infrastructure. You pay everything to the service provider. That is the concept of the cloud computing, in the sense that the machines, your data are not available within your premises. Your premises, you have your desk, right? Your chair, maybe your cell phone, but you do $1 million business without having any of this kind of infrastructure within your premises, and somebody else manages. And of course, you should have a trust. That should be a trusted network. Okay. The larger clouds often have various functions distributed over the multiple locations, span across cities, within a country or outside a country also sometimes. as I told you, so it becomes a reality. The objective of the internet. Internet makes entire world a single village, right? So there is no barrier. There is no barrier over there. Even for example, this particular thing that we are interacting today, right? So through the Zoom, the entire infrastructure, where is it? Or is it available in SRKR? Is it available in my room where I'm presenting it? Right? It is a third party, and even that particular server, etc., may be available outside of the country also. So these clouds basically are located, co-located at multiple locations, each of which is a data center. The data centers need to be done. So the cloud computing architecture, if you look at, so it comprises of the servers, high-end machines, virtual desktops, that you don't have a physical desktop, but there's a virtual desktop, meaning that there will be a keyboard, there will be a monitor, there's a little amount of, uh, CPU power, but all that you are working will be at the servers. All the data that you are pulling will be coming from the server. All the data that you update will get updated to the server. That's why it's called virtual. Then you need to have some kind of software platform for that, and there are customized applications, and of course the storage of the data. So they're all in the cloud environment. Internet is the means by which the connectivity is there. Without internet, cloud computing is not a reality, of course. And then you have the routers, and in your office you have your own mobile phone getting connected with your cloud infrastructure, or maybe a laptop, or you may have a printer connected with the cloud computing environment. And you have various end user applications are available, and there is a internet, I would say the data link layer physical switches, which provides which replicates the internet for all desktops that are available over there. So depending upon the computing your need, right? So it can be broadly categorized into three models, service models, based on the service model. How exactly the cloud computing provides service to you. If you look at it, it can be called as an infrastructure as a service, IaaS. You take only infrastructure, but you take care of developing the applications and operating system. You maintain all such kind of things. Or you take platform as a service, or whether you want to have a Unix platform or already preloaded operating systems. So you don't want to spend much of time, you don't have an expertise on doing that. You can go for a platform as a service. Otherwise, software as a service. Okay, so the vendors would have built their own softwares. Everything's available. You use it. You don't invest on reinventing the wheel. You don't. The company doesn't need to invest upon engaging the programmers, a group of programmers, to develop a software. You can actually use that third-party software installed in that particular machine itself, but you run the business. Based on the deployment, it can be a private cloud, or it can be a public cloud, or it can be a hybrid cloud. A private cloud is preferred if it has to be purely secure and it is established by the parties concerned themselves. Where the public cloud is that it's like a shared medium. All the people will be sharing the resources. So the investment will be relatively very less, right, compared to the private thing. But security-wise, some kind of compromise is expected, but there are robust mechanisms still available. So we also have a hybrid of this kind of thing. So partly it can be a private cloud, partly it can be a public cloud also. We will see in some other slides what are some examples of the public clouds that are available. These are some of the public cloud services that are predominantly used by various people, right? And a small comparison with respect to their services that are offered here. Okay, for example, the Amazon Web Service is very, very popular. Amazon Elastic Computing Cloud, EC2, they call it as the name suggests elastic. The sense that you don't have to pay the rent for the entire infrastructure. You pay as you use. That's a very interesting concept, right? You pay minimum charges, and if your demand increases, right, automatically the building also increases. And then if the demand decreases, the activities decreases, and you pay for what exactly you have used it. So that is called elastic kind of things. Very interesting things are available. There are several models, bare metal instance, dedicated host, container, etc. Then you have another very popular thing, Azure. Google Cloud Platform is a very recent thing. They have also entered into this public cloud kind of things. Yes, Navya, you have some question, you please ask me. Okay. Then IBM is very interesting cloud. IBM also comes out with its own thing at the international level. Oracle also has its own cloud infrastructure, public cloud infrastructure. There is an Alibaba cloud, which is basically from China. Now, having seen what is cloud computing, how does this cloud computing plays a vital role in IoT? How does it help, enriching the IoT, right? So basically, the cloud computing can be used to store the IoT data in a collaborative environment. That is the advantage of it. As I told you, the things generate the data. Every tiny thing, every small thing generates very tiny data. When they generate, it's very, very small. As I told you, it can be as low as 10 bytes only, or it can be few hundred bytes kind of data. Someone is asked, raising the hand. Yeah, I'm open for the questions, or we can have the discussions after I finish this. And if you want to ask question, you can turn on your mic, definitely. Yes. Right. So there is a old saying, uh, you know, uh, every tiny drops make a big ocean, right? So when the rain comes, it will be tiny drops only. But as it continuously rains, it makes a flood of water on the roads, right? So every tiny drop makes a big ocean. So every tiny small data that is coming from different pieces of your things, right? Millions and trillions of the things need to be stored in some shared environment or a collaborative environment. If it is there, then it is not only going to benefit the individual, the owner of that particular thing, but also to other researchers, some other collaborative agents. They can also use it. In fact, it can even give a revenue model also for the people who have launched these kind of IoTs. That's advantage of it. So the computer resources are centralized on a server, which can be accessed whenever needed, right? So this facilitates remote computing, right? You don't have to rely on your own computer. So you have it, and from anywhere you can find it. Like how you people are seeing your CCTV cameras. It's also a classical example of a cloud computing. Okay, cloud computing. It is not a private network. You are on the public network, but at the same time, with a secure layer, you are able to see what happens, what are viewables through your kind of things. What is the computing? If you ask me, okay, computing is only sensing and then compressing it and then sending it across the network. At the receiver cell phone, you just actually see it. Sometimes it can be stored. Sometimes it can even detect some other presences, whether a known person is coming or an unknown person is coming, whether a repeated offender is coming. All these kind of things can be done to all this, right? So remote computing is possible, right? And it provides a secure and private environment, and you have an integrated data management, and then more important is that 24 cross 7. If you look at any service provider, they would say 99%, 99.999% uptime, they would say. Achieving that 99.999%, if an organization or an enterprises has its own infrastructure, it will be, I tell you, really challenging thing. Because battery backup is required, availability of the electricity is very, very important, maintenance is very important. If something goes wrong, right, the time that is required to revive the network varies from, say, a few hours to few days also. And if it is going to take in terms of day, and so much of loss will be accounted for that particular company is considered, enterprise is considered. So this unlocks potentials for connected devices. This refers to the integration of IoT devices with the cloud computing services in order to leverage the scalability is very, very important. Right. So when we establish some kind of computing environment, we plan, okay, this many number of devices are required, this many computers are required, and then when we want to expand, when the business expands, when the need increases, then we have to snatch our head. We have to completely revamp, and because the compatibility issues will come. You cannot buy another sensor, another module, make it compatible with that particular thing. But once you integrate your IoT with the available public clouds, then scalability automatically comes in. You can expand it, right? As I told you, the Amazon, the elasticity comes into picture. You have trusted storage, and then you can enlarge the storage also. The processing capabilities of the cloud is also can be benefited if you use the cloud. So cloud-enabled IoT. Yes, now this has become the game changer of the digital landscape. The scalability and cost effectiveness are very, very important in the competitive world, right? It helps to store the small, tiny data that are coming, and then helps to remotely process, and then even the processed data can be shared in a collaborative environment. It helps to do a remote management of the devices I'm talking about, and then it also ensures security. The enterprise owning that particular infrastructure may not have to even engage a security engineer, I would say. The cloud, the public clouds will upgrade their security services, right? It helps to improve your decision making, and then it gives you a lot of avenues for innovative thinking and then flexibility in your businesses considered. Right. So it helps to enhance the security, right? The agility in the processes, in your business processes, can be multifold enhanced. These are some of the advantages, I would say. So what are the key components here? To again, to reiterate, the IoT devices and sensors, the choice, their sizes, their specifications, everything is very important. Their availability, their versioning is very important. The connectivity, whether we need to have a wired or wireless. You may be thinking, why I'm saying wired? Because sometimes the sometimes the manufacturers of the transducers or the sensors would give only the wired communication. At the wired communication, we have different kind of interfaces that we need to study properly, whether it's USB or whether industry standard IEEE 488 kind of interfaces. All such kind of things need to be considered properly. The cloud infrastructure, talking about the processor, how many cores the cloud has, what is the data storage capacity, what is the backup facility that is available, right? And the privacy, data privacy policies over there, all such kind of things need to be done. Then whether you have components tools for doing a data analytics and looking at the insights of the data that have been gathered. It is not only gathering the data and storing it. We should be able to take some useful data also. So when you dig the data and take some kind of thing, we call it as an information, right? So information, you further dig, it becomes knowledge, right? As you gain the knowledge, finally it takes you into a wisdom. If you look at, and I don't have a slide to say that, the data science, that's how it goes. The data is raw. When it is processed, it becomes information. Further, you process, work on the processed information, it becomes, you gain the knowledge, and from the knowledge, you attain the state of the wisdom. So the cloud-enabled IoT helps in achieving all these kind of things, I would say. Okay, this gets repeated. Well, what are the challenges ahead of this, implementing this cloud-enabled IoT? There are security concerns that need to be governed, right? So time and again, a lot of new threats keep coming. The world is now seeing a lot of, tremendous increase in cyber crimes. So they are all very important issues. Then the privacy issues. So you are on the public cloud. So who are all coming and then taking your control of your devices is a very important thing. Whether your devices are protected by means of privacy preservation protocols is very important. Connectivity reliability is also very important. And today, thanks to all the service providers, and we are migrating from 5G to 6G, almost connectivity issues are not there. But in the absence of unreliable connections, your applications or the services should not end up having some kind of disastrous effects, right? Data management and governance, we should comply with the all the policies. Interoperability from one software to another software is also very important, right? And there's a lot of skill gap. When I say IoT, I already told you we have four different layers, and everywhere, whether it's a software or the hardware or the networking aspects, we need to have the skilled personnel. There's a lot of gap here. Getting the skilled people is a real challenge faced by this kind of cloud service providers and IoT designers. Okay, so these are all some of the real challenges posed by these kind of things. And very quickly, I'll go through the real world examples. Smart home automation, industrial IoT, Industry 4.0, smart city solutions, healthcare, agriculture, and this is not an exhaustive list of that particular thing. Everywhere, right? With the advent of the cloud services and then various IoT devices that are available in the smart city projects or in the smart highway projects. So all these two things work together, and then from one domain to another domain also data and the process information can be exchanged. Very quickly, some of the case studies of leveraging this cloud services into the IoT. For example, the Coca-Cola company, beverage industry, used this AWS, Amazon Web Services optimized vending machines. The challenge that they have had was that needed to optimize their vast network of vending machines across Turkey and Eurasia. Then they implemented an IoT solution using this AWS cloud by way of sensors in the vending machines, track the inventory levels, the temperature, machine and perform, and with the machine performance, and then exchanging it through the AWS helped increase really the productivity of that particular thing. And they say that they were able to save 20% of energy annually by leveraging the cloud into the IoT. 9% they saved on the water annually, 34 days of process time saved annually, all these kind of things. They were able to do this. Yeah. And another thing is there's a company called Deep Sky Vineyard, and the agriculture domain utilized the Google Cloud, right? So basically, they wanted to improve their grape quality and crop yield while using water resources efficiently. So immediately the IoT comes into rescue. So deployed a cloud-based IoT system, of course, with this Google Cloud that help to monitor, soil moisture, temperature, water conditions, weather conditions, etc. And they're all fed into the Google Cloud platform as a software as a service. They were able to do a lot of analytics and then increase their productivity, right? So they were able to control the water waste. They were able to get the real-time data, and then indeed they were able to see optimized growth of the grape using this particular technology. This is another example of the supply chain management, DHL, using uh, another I think from Microsoft Azure. Another company, Dow Chemical Company, okay, major chemical manufacturer, needed to improve the operational efficiency and safety in their plants. They have hired this Microsoft Azure platform. Using sensors, they monitor various parameters within the plants, including the equipment performance, environmental conditions, potential safety hazards, and all that. And that has helped increasing the safety standards through this kind of real-time monitoring systems. They were also able to optimize the production processes. This is another example. I'll just skip for want of time. Yeah, so these are some of the best practices for implementing the cloud-enabled IoT. Right. So if you're into doing some kind of projects, or you want to choose this as a career, first of all, you need to define the objectives clear. If the objectives are not clear, no, this is the basis of your software engineering, right? If the objectives are not clear, then you'll not be able to end up, choosing the proper set of IoT, platform, sensors, and then what is required for the cloud. Choose the right IoT devices and sensors. Select a reliable cloud provider. We have seen some of the cloud providers, some 4 or 5. There are many other not so popular providers also, but you have to select one such reliable and the cost optimized. Ensure the data security and privacy of your devices. Focus on the interoperability, and then you need to again, I mean, after launching this cloud-enabled IoT, if you don't regularly monitor and if you don't regularly maintain that particular thing, then the investment will be wasted. Needless to say about that particular thing. These are some of the future avenues for the cloud-enabled IoTs. Edge computing is still in the research area. It will come. Integration of the artificial intelligence and machine learning techniques already started working well, right? And I don't have time to much discuss about it. And a lot of proofs are available. And connectivity, 4G is what is prevalent today. 5G is available some places, and 6G is going to come very quickly. The blockchain technology also matures enough that will be well suited for IoT. And security for IoT is little more challenged than the providing security solutions for the conventional things, because there are a lot of inherently challenges that are available in resource constrained devices here. These are some other techniques. Well, so having said about different, I would say, the cloud service providers, in India, if you look at Government of India, the Ministry of Electronics and Information Technology, MeitY, has its own cloud, Meghraj, but not, common public can use that particular thing. Only the government of offices, universities, educational institutions can make use of that. Of course, with some kind of protocols are available. And they also maintain a list of empaneled cloud service providers, okay, in India. There are about some 22 such cloud service providers available. Now, one can go through this MeitY and then hire the services that are available here. They periodically publish in their website about their locations where the cloud services data centers are co-located. For example, Mumbai, Hyderabad, Faridabad, etc., Noida, etc. And then whether it's a public cloud or not, they tell. And then the validity period also they say how long they have enrolled with the Government of India also they say. So all these things can be subscribed if you are doing some kind of research, or if you are going to start up your own startup. You don't have to heavily invest. You can go through this Government of India platform. This IBM Watson is another interesting platform. They regularly conduct some kind of workshops for the benefit of the researchers and students. So if you have an opportunity, you can learn. They give you the entire test beds, right? You don't have to have even what you call the sensors. Everything is available. You learn programming. That will help you to secure a very good jobs in the industries. As I just now told you, the industry, there's a lot of paucity of the skilled labor, I will not say laborers, skilled programmers, skilled engineers. Just, coming out of 4 years of degree is not sufficient. They really want to have some skilled programmers. Knowledge in programming in C, C++, Java itself is not sufficient. But beyond that, you should know various technologies. So you please learn. That will help you doing that. This is an example of the Oracle Cloud Service. For the researchers, I would say these are some of the open research problems. There are a lot of optimizations that you can do, make the protocols energy efficient, because the endpoint devices are energy constrained. Please remember, they are energy constrained. They are typically deployed in very difficult to access remote places. So a lot of interesting problems are available. And the short range communications, especially the 6G, etc., they work well in a very, very small distance only. So how do we address the multi-hop solutions? Intermittent last mile connectivity problems need to be addressed. Handling of the large data that is coming from thousands of sensors, right? The data cleansing policies, how long we can keep the data, which data need to be removed, kind of things. Privacy preservation is very important. So we can come out with interesting ideas of privacy preservation protocols, and then other security protocols at the application layer, at the transport layer, at the data link layer also. These are all several research open problems available where people are still working and publishing their papers. Well, I'll stop up to this. So what we have discussed for the past, I would say, 70 minutes or so is about the cloud-enabled IoT. We started discussing about the root of the IoT. I said it is internet first, then the wireless technology, then the wireless sensor networks. We have discussed about IoT architecture, a four-layered architecture. So that is where, as students, you can, fit in into that particular area. As teachers, you can identify the students where they are inclined to do so, and then they can motivate. And I have given you a glimpse of what are the IoT applications. And we have also discussed about the challenges of the handling of data, IoT data, and how do we leverage the features, benefits of the cloud computing for IoT. We have seen with some typical case studies with various companies, and finally we ended up with open research problems. I hope I've done with it, kind of things. But before that, as I told you, the companies really need, they are in need of skilled programmers. So these are the areas where you need to develop, right? If you want to go into the IoT, Node.js development is very important. Mobile application developments, API automation, user interfaces, all such kind of things are required. But on the other hand, if you want to, work in the cloud computing environment, several APIs available. You should get fair knowledge in that. Network management, DevOps, of course, the machine learning and AI algorithms. If you learn, then you certainly will grab a job opportunity taking you to, I would say, 25 lakhs per annum is certainly eligible for it. Well, thank you all for your patience listening, and I'm open for the questions. If you have any questions, please either you type it or you can turn on your mic and then ask me. I'm open to answer and interact with you.
I request all the participants to ask the questions regarding the webinar. You can unmute.
Okay, anyone wish to ask any query? Just raise your hand. We'll unmute you.
Okay, there are no questions. I thank the organizers of this webinar, especially the Department of Computer Science, HOD sir, faculty members, the IEEE Students Chapter organizers, Divya, and all other organizers. Thank you very much.
Sir, I request all the participants to show their videos, sir, to on their videos, sir. So that we can take one screenshots.
Yeah.
Thank you very much, sir, for your elaborated information regarding Internet of Things and cloud computing along with IoT. It is very useful for our students to migrate from simple Internet of Things to how to use the cloud services in Internet of Things. Thank you very much, sir, for this session, and hope the same type of technical support needed from you in future also in conducting various other workshops also, sir.
Sir, I request Priyadarshini Madam to give vote of thanks.
Thank you, sir.
Good afternoon, everyone. Myself, B. Priyadarshini, Assistant Professor in Department of CSE. And I'm so much delighted to propose vote of thanks on this occasion. First of all, I'm so much thankful to the resource person of today's webinar, Dr. K. Selvaraj Garu, for sharing the information about cloud-enabled IoT, which is very useful in present scenario. Thank you so much, sir. And a special thanks to our management for their continuous support in all the aspects of conducting various events in the department. And next, I would like to thank our principal, Dr. K.V. Muralikrishna Rajgaru, and our director, Dr. M. Jagapati Rajgaru, who always encourages and supports all the faculty and students for the professional development. And My sincere thanks to our HOD, Dr. V. Chandrasekhar Garu, who has been a main pillar of CSE department, and he always supports us to conduct various webinars. And for conducting this webinar also, thank you so much, sir. And I would like to thank all the faculty of the CSE department for the teamwork so that this webinar was a great success. And finally, I thank all the students and faculty in and around the college who participated in this webinar, because their presence and the cooperation only made this webinar successful. And thank you all. Thank you, everyone. Thank you, sir.
Thank you, Selvraj, sir. Thank you, Chandrasekhar, sir.
Thank you, madam. Thank you.
Thank you all for your patience.
Once again, thank you very much, sir. Selvraj, sir.
Yeah. So later you can get the feedbacks from the participants. Okay.
Yes, sir.
Yes, sir. Yes, sir. We'll get the feedback and we'll share it with you, sir.
I'm delighted to see all those kind of things.
Okay.
So, if time permits, I'll make a visit once to your SRKR college. Okay?
Thank you, sir.
Thank you all. Have a nice day.
Thank you. Thank you very much, sir. Thank you.
సార్ ఒక 5 minutes నుంచి క్లోజ్ చేద్దామా సార్?
అలాగే అది ఫామ్ తీసుకోమండి. All the students are go through this chart and get the feedback form and fill it and submit. Then only you have to get a certificate.
Thank you all. I'm ending the meeting. Within a week, you will get your certificates. To the email which you have given, to that mail, we will send the certificates. Is it okay? Thank you. I hope everyone have filled the feedback form. I'm ending the meeting.